And we are live. Welcome everyone to SQL Friday. This is SQL Friday number 60, and our guest today is Taiob Ali, or Ali. I don't know how to pronounce it correctly, but you tell me, Taiob.
No, you're good. Good.
I'm good. Okay, thanks. The topic today is how to think like the Cardinality Estimator, and I'm really looking forward to it. Welcome to SQL Friday, and thanks for getting up early for us today, Taiob.
Okay, thank you, Magnus. Thank you for inviting me. This is an honor, speaking to this series. I've looked at the speaker lineup, pretty good, and it's very consistent. And I thank you all those who attended. I know for some of you, I don't, it's probably in the middle of the working day, probably 10 a.m., 11 a.m. in Europe. So I appreciate that you're taking out, some time from your work or from your busy schedule and listening to me, and I don't take that lightly. So let's move on. Hopefully you learn something at the end. And one thing is there is no bad questions. So please put in the chat, and I'll also share my contacts. Actually, let me go to the next slide. So if you look on the left side, you can contact me with any of this. I pretty much monitor all this. And if I do not get time to answer any question, or if you have any follow-up comments, I will definitely get back to you. That's for sure. And sometimes, I do not know the answer, I'll be honest with you, but I know some people are smarter than me. I reach out to them, I get the answer, and then I bring it back to you. But you will get an answer from me, that's for sure. So I'll never ignore your, your email or whatever way you contact me. So these are a few things we'll be talking about. And first, I'll try to make a case that why you should be listening to this talk, or why you should be cognizant about cardinality, what impact it has when we are using SQL Server engine. Because unless we appreciate that, this talk will not really mean anything to you, right? If you do not know why you should be knowing this. And then we'll go to the second part, is what you can do about this, right? And sometimes we really cannot do anything about cardinality because it's the way the engine written by the Microsoft engineers and architects. But when we know how the engine works, I think we can influence it, indirectly by rewriting our query, or with some hardware change, whatever, and we'll probably not touch that area too much. It's more of knowing how these numbers are getting generated. So let's talk about some definition to set the baseline, because some of you are pro. I know you're probably working with SQL Server for a long time. So just bear with me, because I always present this talk assuming that we might also have some people new to this industry, right? They might not know these terms, so it won't be fair for them if I straight go to the little bit advanced topics. So and it's always a refresher doesn't hurt, right? I mean, I always prefer that. So first one is a predicate. So the cardinality estimation process is really interested in the predicate that we define in our query. Now, a predicate is an expression. It can evaluate to true, or it can evaluate to false. Now, there are also, it can be unknown. Sometimes we just don't know. Null is a big topic within the SQL Server engine. Doesn't matter whether you're on premises or in cloud. There are talks and there are articles has been written just how to deal with null. So if I go there, we'll be talking about that for a long time. So, but just keep in mind one thing: null equals to unknown. A lot of people get confused. What does null really means? It just means I just don't know what is there. Don't think that it's empty or it's zero or anything. That's a misconception. Now, let's look at an example. Right? This is a very simple query. We are doing a select from two tables. Now, there are two different kind of predicates. The customer ID, we call this is a join predicate. And below that, if you see the order date and the count after you do a group by, those are called filter predicate, right? We used it with where and having. And this is important because your filter will have an impact, or how many rows the cardinality estimator is going to estimate when it qualifies, how many rows sending to the next operator. Now we talked about predicate, and now predicate also have a selectivity. The predicates that we are using also have a selectivity, and that also have an impact on our cardinality estimation. So what's predicate selectivity? And as you can see, I put a formula here. It's pretty much the fraction of rows from the input set that qualifies to move to the next operator. And so maybe we should just look at an example, right? Because sometimes these definitions can be very raw and hard to grasp. But because we all write TSQL, if we look at an example, maybe it gets clear to us, right? So here, as you can see, I said customer ID equals 577, right? Now, I don't know at this time, right, that how many will qualify. So that's where the selectivity comes. If we do a count on customer ID 577, we can see that it qualifies for 75 rows. Now, out of how many rows? Out of the total number of rows is 73,595. So if you divide 75 by that total number, it comes to 0.0010. So that's our selectivity for this particular predicate. And this also has a huge impact on your cardinality estimation. And that leads us to the next one, is called density. So every column in a SQL Server table has its own density, means how often you get a duplicate value in that column, right? So if you have a column, say like in United States where I live, say by state, right? Each state will qualify many people. But if you're using a predicate name like city, you see, then the number gets down, right? Then even within the city, if you divide it more, it comes down. So that will also have impact, right? Because when you are, creating your index or just looking at that column, right? If it's a state, you'll see a lot of duplicate values, because in a state like New York or California, there's, millions of people in the same in a state. So the higher your density means less unique rows. The lower density means it's more unique rows. So just keep that in mind. And this is another example, right? I'm looking at a distinct customer ID in the sales.orders table, and there are 663 distinct tables. And then that's our density of this column. And this number that you see here, 0.001508 that are highlighted with yellow, has a huge impact. We'll see in many cases when we write our query and the query engine, if we do not have an index or that's not the leading column of the index, and even if you have an index, there will be situation that the query optimizer cannot estimate accurately, and many times you will see that this number will get used to do the calculation, and we'll see those when you go to demo. So what's cardinality estimation? I'm not going to read this, but each operator in a query plan has a estimated cardinality, means the number of rows that the optimizer guessed that it will return to the next operator. But it also has an actual cardinality, right? So if I say, maybe let's move to the next. As you can see, this is a screenshot from a properties of a clustered index SIG. And, this is a small number, right? The actual number is 12, but the cardinality estimator estimated 7.6. So round it up, say 8. Now, is 8 and 12 is going to make any difference? No. But, some of you are not working with 8 and 12s, probably you are working with millions or billions. So imagine if the cardinality estimator estimated 8 million and your actual number is 12 million, you have a problem. And we'll talk about that, what the problem is, and then why should we look at these two numbers. So what's our goal? Our ideal will be if I see the same number. My estimated number and my actual number is same, that will be the perfect world. Does it happen? No. Even if you have most up-to-date statistics with 100% sample with full scan, you still will have instances where your actual and estimated numbers will differ. And we'll look at some of those examples. Now, why does it matter, right? I've been talking about for about 7-8 minutes. And I've been talking about estimated and actual numbers, that if it varies, I've been saying all the time that there's a problem. So what is the real problem? So let's look at that. What happens when you submit a query to SQL Server Engine? There are a few phases, and this slide itself can be a 1-hour talk. And there are masters in this area. One I can remember is a Paul White from New Zealand. If you want to talk about, and there's someone in California. There are a few folks expert on this. They can walk you through this one slide. Maybe they can talk for hours. But in summary, whenever we submit a query, the first phase is called parsing. So a query gets parsed into a logical tree just to check that if the logic makes sense of our query. Can the query optimizer or can the SQL Server engine or the query engine can process this query, right? If it thinks that it cannot create a logical tree, it will throw out an error and it stops there. Now, once that phase is done, then it goes to transformation phase. In transformation phase, what the query optimizer does, it looks at equivalent variations of the tree. So it sees that I can process this query this way, or I can do it that way, right? So it checks all the variations, but all of those has to guarantee the same result set. So just keep that in mind. We cannot be having like 2 different logical trees and getting 2 different set of results, right? That doesn't work because you are guaranteed to get the same results. It doesn't matter which path it takes. The next phase is the cardinality estimation, and this is where this talk is about. In this phase, the cardinality estimator estimates the number of rows that will be flowing from each operator to the next one, right? From each one. Now, based on that number, each operator get a cost, and this whole engine is a cost-based engine, right? So all those costs are going to get added, and the cheapest is the winner. And why the cheapest is the winner? The lesser your cost means from the hardware, from memory and CPU perspective, I have to spend less CPU cycle and I have to spend less memory because you are less expensive. So you are the winner. And then that query plan get put into the cache. So next time if you call with the same query, now each query get a hash. So if the hash matches, so I do not have to go through this first 4 phases. I can instead go to the number 5th phase, means I can go to the plan cache and get the query plan that was in the cache and then just go to the query execution phase. So that saves you the first 4. Now that also has a problem, which one of the problems is called parameter sniffing, which is very common. We'll probably touch it briefly in the demo, but and I'll show you how to identify that. So this is all good, right? Now what happens if the cardinality estimator goes wrong that we've been talking about? It means you can get a bad plan, slow query. It might use excessive resource because your estimation was wrong, or you may be getting less resource than you need, and then you run into other problems. Determines the order of operation, physical algorithm, join order, access path. There's a bunch of things get affected on that. One of the big topic is a memory grant, because we have finite memory in a SQL Server engine, and if your estimations are wrong, you're giving out more memory. And imagine if you have the same query from many clients with different parameter values, and everyone is getting more memory than they need. Eventually, you'll run out of memory to give out, and then your queries have to get into the queue. Again, that itself can be a long talk. So let's move to the next one. So I said, I kind of touched this, but I want to put a slide on this to go into a little bit more details, like what are the problems here? A SQL Server, based on your setting, there are 2 settings, one called cost threshold or parallelism, and one is we call max drop. Depending on that, some of the queries can use more than one CPU. And within a query, not every operator can go parallel. Some of the operators can go parallel. But how does SQL Server decide which operators can go into parallel and which operators should execute serially? Totally based on the cardinality estimation. So imagine if you estimate high, you send this query into parallel mode. Now, so now it needs more threads, means more of your CPU is tied to this query execution where it could have, served the other queries. And just so you know, once you are tied to this query, those CPUs will not get released till this query is finished. I touched about memory grant. This is huge. This is huge. If you give it more memory, you have problem because you'll run out. If you give it less, you have other problem. Because if you give it less, now if you need to do a sort or you need to create a hash bucket for a hash join, you don't have enough memory, then what happens? The sorts have to spill to tempdb. And when you say spill means because I do not have enough memory you didn't give me, now I'm going to do this sort into tempdb. So imagine this. Now you have to go to disk, write all this, sort it there, bring it back to memory again. And you might say that, oh, now I have SSD, I have Ultra Disk in Azure and all that. You're still talking about microsecond versus millisecond because the memory, it's way faster to doing it in memory compared to doesn't matter what disk you go to, right? Because yes, you have Ultra Disk, but remember you still have the network path. You still have to go through, there's bunch of components from your memory and writing back to disk. This is method, right? Seek, scan, or you can do a seek plus scan. So if you estimate a lot more number of rows, then you really will qualify. The engine might decide I'm just going to do a scan in this case because I have so many rows to read. Whereas you could have done just a seek and probably a little bit of range scan and then come back. So it impacts that. Join is a huge one, and you will see there's a lot of YouTube videos, there's a lot of articles about join, especially instead of a hash join, sometimes if you choose a nested loop join on a large data set, it can be brutal for you because nested loop join is a row by row. And yes, there are places for nested loop join, don't get me wrong. It works perfect if your estimates are correct. But sometimes you will see like, hey, my query was running nice at 10 o'clock, 11 o'clock, I'm just sitting there. Someone will come and complain because it picked a nested loop join for, probably millions of rows. And now you're grinding through from the top one row going to the bottom one and just keep doing it. And in SQL Server 2019, Microsoft released a thing called adaptive join. That's not a part of this talk, but to solve, this is one of the main reason or one of the primary reason to come up with adaptive join. So on the fly, SQL Server can, decide, what kind of join I should do. So hopefully, up to now, I'm talking about 15 minutes. Hopefully I made enough case that, that you will appreciate that why we should be knowing how the estimated number of rows are selected, based on, and this is not a comprehensive list. I'm sure there are other things that get impacted, but I just highlighted a couple of those so you can appreciate that. Now, why does this thing go wrong, right? You might ask, why can't just this estimate correctly, right? Then I don't have to give this talk. We don't have all those problems. Why cannot, Microsoft has all these brilliant engineers. Why can't they just write a algorithm, that will just always estimate the correct number, and it just doesn't happen. And this is some of the reasons. Missing statistics, stale statistics, because imagine if you're in a OLTP shop, right? On the Christmas or, on the, we call it Black Friday in US, people are shopping, imagine like in Amazon, right? I don't know how many millions of orders they get every second, right? And if you have to update your statistics with every change in your table, it's just not practical. So statistics will get stale. Now you have to decide as a data professional at what point I update my statistics. And then the next one is, in the third bullet point, if you see sample rate, right? If I have tables with billions of records, do I go and update my stats with full scan every time? Again, it's not practical because you just don't have the time, and the IO storm is going to create. It's just not practical in this case. And even if you do that, even if you do all those three in the top, remember, and I'll show you in the histogram, you only get 200 steps. Doesn't matter if you have 2,000 rows or 2 billion rows. Your histogram, the maximum steps is only 200. So when the estimation happens, it can only get information from the histogram, even though you have perfect stats with 100% sample. You only have 200 data point, and anything in between the 200 you have to estimate, and I'll show you those. And then I talked about parameter sniffing and out of model query constructs. And when I say out of model query constructs, if you are more into development, which I'm not, but I get this, when developers, after they write this, they want to tune, and they see some bad performance, they'll come to us or my team. Some of the examples like multi-statement table value function, table variable X query, and actually Microsoft is making some pretty good progress starting SQL Server 2017 with the intelligent query processing. So Pedro Lopez, Joe Sack, actually leading that team and doing brilliant work. And actually they have two more new features went into. It was in public preview, went to GA in Azure SQL, and it will come into on premises. A lot of these things, because of the out of model query constructs, they want to adjust these things on the fly during the execution. Or after the first execution, look at the runtime stats and make a adjustment on the second, iteration. And I have a 1-hour talk just on those features, but there are other people also gave talk. And if you go to Microsoft website, they have, on GitHub, there's a bunch of examples about those new improvements. So I would highly recommend, if you're using 2017 and 19, look at those improvements. And those are good tips if you want to entice someone for upgrade. Show them those. They're pretty cool because you do not have to make any change in your application code. Just by upgrading to the new CE, you can enable those features. So we talked about stats a lot, and so let's look at a histogram. So histogram has 3 sections. I'm not going to read this. I put this mostly for for your reference because we'll be looking into more details. And this is a time I really encourage you, if you do not get this next few slides, if you do not understand these numbers, please put it in the chat, because if you do not understand how to read histogram, and if you're not 100% clear, I'd rather stop here and let's talk about this. Because if you can get this thing right out of this talk, even if I do not get time to do any demo, I think that will be worth our time together here. Because reading histogram correctly, I see a lot of people still get confused because your cardinality estimator is actually reading from this histogram directly. So if you know how it is reading and you can read the same way, then you are halfway there, to understand how these numbers get generated. So as you can see on the header, you have these columns, and there's a density I put deprecated because there is another density in the second section that is used. This is deprecated, but Microsoft rarely remove deprecated features. If you're working with SQL Server Engine, you probably know better than me, because they're always worried about backward compatibility and what will break, so they just leave it there, and they will always put a note in the documentation that it will be removed at any point, so do not use it. But this is not a criticism of Microsoft. They do it for the wider customers' good, right? So here, if you notice one thing that if you look at the top, it says rows 50,299. But if you look at the bottom right, maybe I can use if you look at here, it says 73,000. But look at here, it says 50,000, right? It can be 2 reasons, because I did not update my stats with full sample, or I have a filter expression. So you can have statistics created with a filter expression. But look at this steps 200. This is what I was talking before. Even if I have a 2 billion record table, I will still get only 200 steps. So keep that in mind, and we'll look at those. This is the next section they call density vector. And this density is crucial. It will get used in many formulas. We'll see during the demo. This particular index has two columns. One is, as you can see here. So they create index for the leftmost column, then the next, with the next one. And if you have three columns, you will see another row with all three columns. And it used the formula, as you can see, I kind of put it here, right here, right? And I showed it in one of the slide too. Now this is the histogram, and these are the columns. So if you see that I highlighted a section with red, I took that and make it a little bit bigger. And this is the slide that I was talking about. If you do not understand, please ask me a question, because this is crucial. So I'll spend a little bit more time and try to explain each number here. So if you look at these two rows, 2083 and 2091, that's our leading column, and you only get histogram on the leading column. A lot of time you will see that I see question in Stack Exchange and in other social media that I have column A, column B, column C, and then why do I need another index with column B, column A, or whatever, right? Why they are not same? Because if you have a index on column A, B, C, you only get histogram on column A. That's the only one you can use. The column B and column C is there because your query probably is selecting those columns also, so you do not have to go to disk to get the value for those, those columns. You can just get it from here or to your data page, sorry. Now, if you are running a query, if you say like, give me some result set where contact person ID is 2083, for the query engine is pretty simple. It will come to the column, the third one, where it says equal rows, means it knows exactly for this value, we have 119 records. Pretty simple. If you say, if my contact person ID is 2091, give me this data. Also very easy, because equal rows is 106. All good. What happens if I pass anything in between? If I say contact person ID is 2084, 85, 86, 87, 88, 89, 90, that's when it becomes interesting. So what information does histogram have? If you're talking about anything in between, do not read the top line. You read the second line. So the line with the 2091. What it's saying that I have range rows 332. What does this mean? It's saying for all the IDs from 2084, inclusive 2090, I have 332 rows. It is not saying how much for which one. It doesn't know. It also says that out of those, I can only see three values. Means 84, 85, 86, 87, 88, 80, oh gosh, sorry. Out of those 7, we only have records for 3. And the other 4 doesn't have any records. Does it tell you which other 4? It does not. For those 4, you have 0 record. So even though your stats are 100% updated with, just now you updated, there was not a single modification with 100% sample, you pass a predicate value between 2084 and 2090, what happens? It's a guess. Like I said, out of 7, 4 doesn't have any single record, only 3 has record. And even if you hit those 3, it divides 332 divided by 3 is 110.66. So you'll always see that my estimated number of records is 110.66. Does all 3 have same 110? No. Some might have 1, some might have 200. We don't know. So this is what I was trying to tell you. Even you do your update stats 100%, even Microsoft has the most brilliant engineers in the world, we will hit the situations that we do not have any control. But at least now you know that, hey, I updated my stats just now. Why still I get these wrong numbers? Why still I'm getting 110.66 when 2086 doesn't have a single record? Why cannot this engine give me the right number? Because of this. And you cannot do anything in this case unless you stop querying with that ID. You have no control. So I'll pause here. If anyone has any question on these numbers, I would, I want to spend more time. So please let me know, because this is crucial, and I find a lot of people struggle a little bit, to understand these numbers. If not, I'll move on. But Magnus, if you see a question, let me know. So now I briefly touched null, right? What happens if my table has a column that allows null? Because you can write your table definition that will not allow any null. That's also, you can do that. And for some valid reason, yes, you should do that sometime, right? That this column cannot be null. So if someone trying to insert records into that with null, they should get an error message or a friendly message, I would say. So if you have null, because I get this question a lot, you will always see null at the top in your histogram. And it tells you exactly how many records are null in this table. So it's saying that I have 3085 records for that column, null. And what does that mean? Null means, we talked about it, I don't know. It's not zero. It's not empty. I do not know, unknown. And the next one is a date time stamp. This one has 6 rows. And I try to explain what does this mean. So if you do a count 1 or count star, a lot of people debate about this, both are same. You will see this total number of records. If you put the column name, it excludes the null. And if you do this subtraction, you see these are null, right? Now, if you do a query with the second value, it knows exactly I have 6 records. If you say less than that, again, these records are really not less than this, right? These are unknown, so it will just give you 1. If you say more than that, then it knows exactly 75110 minus 6 is 7050. So if you notice this 1, right, what does this mean? Why I've been saying that it's unknown? That's why it didn't say that it's 3085, because those are really not less than January 1st, 2013. Those are unknown. So okay, so I'm really done with the slides. These are some of the stuff that I'm going to show you in the demo. And I'm using SQL Server 2019 CU2 on-premises version running in my laptop with a management studio. No other fancy tool for this demo. And so I'm going to take a small break and set up myself for demo. And I'm going to stop sharing for a minute. I'm going to share a different screen. So give me a minute. Okay, hopefully you can see that.
Yep, we see it.
And now I do not have slides, so I can watch the chat also. So again, stop me if you have any question at any point. Okay, so all these are in my GitHub repo. You can download. A lot of stuff I copied from other places, and I made sure that I gave enough credit. So because oftentimes if I find stuff for free and I take it, but I always put the reference, there's no harm on that, right? I don't want to do something that somebody already done and then it works for me. So this is set up. I already ran this. Wide World Importers is a Microsoft, so you can get it from the GitHub here. And then it's provided by Microsoft, free to use. There's no no data that confidential or anything. This is for community use. And then I'm going to use this table a lot for my demo, so I did update stats, right? to prove that point that I've been talking about, that even if you update with, you know, the 100% sample, you will still have issues. So, and this is what is a Dbcc show statistics is a command that you can run. And these are the these are the three sections that we saw in the slide deck, right? This is the top one. Again, 200 steps. This is the middle one, and then this is the histogram that we talked about, right? So what I did also, and this is really not a too technical slide, you know, because sometimes we come here, we look at these numbers, right? There's so many numbers. If you're new to this, sometimes people get overwhelmed with these numbers. People think where these numbers are coming from, right? These are magic numbers. I have no clue. So what I did is just to put people at ease. If you're new to this, if you're a veteran, don't worry about it. I just wrote some simple TSQL with a union all to prove that these numbers are not something that we cannot figure out. So I took, again, sorry, what's going on here? Oh, so I regenerated some of those numbers with the TSQL from this histogram and all these numbers from the top. The reason I do this just to make a point that there is a formula behind it, right? It's not just a black box that we have no clue. You can do it yourself if you want to, but we don't need to do this. We don't need to write this TSQL and try to figure out all these estimated numbers, right? Because Microsoft has done this for us in a nice and nice format. But again, to put people at ease, again, like, I just did this just to have some fun. So take a look if you're interested. Otherwise, don't worry about this, this particular query. So. Okay, so let's move on. So the first one is I don't think so I need this anymore. Okay. So first one is a direct hit, we call, or it's a single predicate. Again, you're looking at the sales orders table, contact person ID, and all of this, when I'm going to run this, I will turn on actual execution plan. You can do it from here. Or you can, there's a shortcut Control+M, you can do both. And there is also something called estimated execution plan. The difference is you do not have the runtime stats, right? It's just giving you the query plan without the runtime stats because it didn't run yet. If you look at the execution plan, you have the same plan, but you have now the runtime stats. That's when you can see the difference between the actual and estimated. So let's turn this on. I'm using this just so you can see. If I press Control+M, you don't know what I'm doing. And if we come here now, hopefully my magnifier will work. Okay, good. You can see here, estimated is 89, and not the number of rows, sorry, okay, the bottom one, my actual is 89, right? It's a perfect match. So how did this happen? Where did this number come from? If we come here, and 25, I told you if it's a direct hit, look at equal rows, 89, right? So this was a perfect case, was very easy, came to the histogram, saw there is a range high key with 1025, came here and picked up 89. Now, what will happen if I insert bunch of records with 89, right? Sorry, with 1025. So just for the sake of this, for the demo, what I did is I inserted another 2,759 records, all with the ID of 1025. And did the statistics get updated? This is 5:42 my time, so it's about an hour ago. Means the statistics did not get updated once I inserted this 2,759 records. When does the statistics get updated? That's another whole topic. There was a major change in SQL Server 2016. Before 2016, it was 20% plus 500 records, and that caused problem for bigger tables. Microsoft had a trace flag 2371 people could use, and people are using it for large systems. In SQL Server 2016, trace flag 2371 became default in the SQL Server engine. So now it adjusts based on the number of records you have in your table. So again, that's another topic. So in this case, it did not get updated, right? Even though we inserted 2,700 records with the same ID. So now, and I'm just going to clear the cache to be fair for the demo. Now, if I run the same query again, what will happen? Oh, 89 before, right? If you remember, now we see this 92.3365. What happened? Stats didn't get updated because if I run my stats, 1025, it still has 89. So I've been saying if it's a direct hit, you come here and get this number. Now what happened here? Why it's not 89 anymore? Microsoft did something smart that they try to slide it up a little bit when it realized that there are new records since the last updated stats. And this is the formula. That's how this number came from. So what it did, it knew that it was 89 and the total number of rows, and then it also does a look at the current number of records. And this is a hard-coded formula. It takes that number from equal rows, divide by rows and stats, and the new row count. Can you do anything? No. This formula is hard-coded in the engine. So there'll be a lot of time we'll see that we have no control. We really cannot do anything. We cannot change this. But now at least you know, hey, I was seeing in my histogram it still is 89. Why I'm getting a different number? It's coming from there. Let's move on. So let's pick up something else from then 1025. Now it's 1057. And with 1057, now it starts getting interesting. Our estimated number is 123. Number is 109. Now you see it start varying, right? Now it's not same anymore. Where is the 123 coming from? If you remember, no. Okay, I'm going to go back. Actually, I had a note here to run this. So give me a minute. This is my bad. Because I inserted some new records, I want to reset this. This will be a good time. It's going to take us 30 seconds probably. Any questions or comments?
You're all too shy people. If you have any.
Okay, no, that's fine. I'm not forcing anyone to ask anything, but this will be a good time to. Okay, so I'm just going to run this again. Good. Okay, so now I got what I was expecting because it threw me off a little bit because I didn't follow my own instructions. So it's a 118 and 109. So where is 118 coming from? You see this? Right? We passed 1057. What I told you that 1057 falls in between these two. So any values we pass between these two, we go to the bottom one. It has 356 records for the range, have 3 distinct values. Divide 356 by 3, 118.667. Now, we got lucky in this case, right? Because they're not really very far, right? 118.667 and 109. What happened? And I don't know, I'm just taking a guess. So like go to 1056 maybe. No records, right? 0. But you come here, You have the same estimate. So any value I pass from the range, it will always give you this 118.667. So that's why if someone asks you, hey, and you might get this, especially from new developers, nothing against developers, without them, will not have a software. They'll say, hey, can you update your statistics? Like, why? You see, I'm getting this. It's, it has 0 rows, but it's giving me this 118,000 or million records but there's no record. So you start saying, no, because he or she didn't know that, they are passing a value from the range, right? And SQL Server has, it cannot get an exact number. So now you know that where it's coming from. Distincts are, they work pretty good. If you do this, $663, and the reason it knows this, again, if we go back to here, I said many times this density number will get used a lot, right? And I think I showed the formula in my slide. Where is this 663 coming from? Right here, 662.99, and round it up to 663. So it can use that density for many reasons. So that's about single predicate. We're doing good on time, so it's good. Multiple predicates. So of course, we do not just pass one predicate, right? If you're writing a complex query, you will have many. So let me get to the right database. Now, this is a long comment, and I put this purposely. So I'm going to go to the bottom here a little bit. I'm actually going to combine these two predicates into one. But if I just talk about this one, I feel like people, I'm cheating people. I first need to talk about individual ones, right? So this one get this number, this one get this number, then those two numbers get manipulated, and you get a newer number here. Now, where does this number come from, right? We talked about single one, right? Contact person ID equals this and that. What happens if I do this? It gets complicated, right? How this get calculated. And because of the shortage of time, now mostly this talk I give is an hour, it get complex. So, and I mentioned Paul White. I actually, I literally, I think I wrote this here. I have few email conversation with Paul White because, when I'm, pushing this to public, I want to make sure that, my understanding is 100% correct. I didn't want to, spread misinformation. So I did email to him. So where does this 342.625 come? It actually have to 3 different steps to calculate that, right? And imagine if this range is bigger, I only have 1024 to 1027. If you have like say 1024 to 2024, you probably will have many steps, and you have to add those all together. You have to go step by step. So I'm not going to read this for you, but if you are interested, read this. Also, what I did is I put 2 URL here. I think both of these were answered by Paul White, these 2 questions. I love DBA Stack Exchange. I think it's a very rich, high quality question and answer forum there compared to many others. So read this. I'm not going to, there's some good info if you're interested. And I try to break this down each step, how these numbers, where it's getting from the histogram, and eventually how do we get to 342.625. So just to look at this number one more time, this is the number that I was talking about, right? 342. As you can see, it didn't match. It already, it's 201 and 342.625. And if you run the next one, I'm not going to run, you will see this number. Now, what happens when you combine these two? This is where 2014 made a huge difference. So since, I don't know, like SQL Server, people talk about, I don't know, 3.15. I haven't worked on those. I came up from a different background. I started working on 2005. But 2014 is the time Microsoft rewrote the Cardinality engine. So a lot of things changed. So especially there are clear guidance if you are upgrading to 2014 or a higher version. How do you, make sure that Cardinality, the new engine, is not tip you over to a bad query plan. But again, check those out. So if we run this here, if you see this number 44 and actually it's 211. Where does this come from? So the major difference, this is for the newer engine. This used to be the old engine. If you've seen the old engine, everyone has the same weight. But on the new engine, what it says, they have a mathematical term for this, exponential backoff. What does this mean? It's saying that it gives a weight based on your cardinality. So first one, you get full weight. Second one, you get a square root, just to reduce the impact of that cardinality, because it has less impact, or it will qualify for less number of records. And the more you go, if you have more of this, it will get, as you can see here in the formula that I wrote, you get 3 times the square root, means your importance is diminished as you go further. And I kind of wrote this, try to in a simple English. Given a table with cardinality C, the predicate selectivity is this, and if you are most selective, then you get full weight, and as you go to the least selective, your impact is going to be reduced. So now if we run this for that particular query that I ran, if you're on the newer cardinality estimator, you get 44 records, which you saw. But if you'd have run this same query with the old cardinality estimator, it will actually only qualify for 4 records. But the actual number remains, of course, same. As you can see, the top one is comparatively better, not perfect yet, and it will never be perfect. Like we said, we saw many cases that they cannot make each one perfect. Is it always going to be better with the 2014? I cannot guarantee that. I'm sure if you work hard, you can come up with edge cases that it will reverse, and it does happen. That's why when you upgrade, you want to be careful and test. Same happens with OR. You see here is 1404, and the formula for that is right here. As you can see, with the new one is 1404, old one is 1492, again closer to the actual number. But like I said, you can. And how do you run this in the older one, right? So there are 2 ways you can run this. You can have a trace flag just for this query, and this will force it to use the older cardinality engine. But I would not recommend to use that. I just put it there because that's the option. I would rather you use this hint. That's more recommended way. And then I put more comments if you have time. If you are interested, use this and run this. It's just I know I'll run out of time. That's why I put those in comment. I talked about parameter sniffing a few times. I just want to give you an example, and how you can identify and what you can do. So I'm just going to create a simple store procedure, very simple, as you can see here, just a select. Now, if I execute this for first time, if you remember, I showed you it goes through a bunch of phases, right? And as you can see here, we saw before, it's perfect, right? 89 rows, looks very good because we pass 1025. Now, same query. Actually, one thing I want to show you before. If you ever not sure if you are hitting parameter sniffing or not, you do not have to go anywhere. Just get the plan, come here, look at these 2 values. Your plan in the cache is compiled with the 1025. Your runtime is also 1025. Means you do not have a parameter sniffing. You are your golden here. What happened now? I run the same query or same store procedure. I called it with 1025, right? First time. It got saved in the cache. Now I'm calling it with 1057. Is it going to create another plan? No, because the hash value of this and this is same. So it will say that, oh, I already have a plan for this. Let me go to the cache and retrieve it and run it. So let's run it. What happened now? Remember, we were supposed to get 118.6667 something we saw before for this, but now we are still getting 89. What happened here? And this is exactly what people call is parameter sniffing. Look at this now. My compile value, because it got from the cache, but my runtime value is 1057. Now, is this a problem? No, this is not a problem. This is a good thing for us, the way it's designed, right? Imagine if you go to hospital every time, what do they do? Check you in. First name, last name, date of birth. First name, last name, date of birth. You do not need to compile that every time, right? Because you probably have an index on this first name, last name, date of birth. You go and just seek that people and the record comes up on the screen, whoever is talking to you. You do not need to compile this every time, but there can be a problem, right? Say like, you folks are in Sweden, there may be a small city. You've probably first time ran it with a population of very small number, and then you run the same query for a huge, big number of city. Now you can run into those problems with a nested loop join, versus other stuff. Now, we saw that, this is a problem. Now, if I clear the cache, and this is a, to clear the cache, you might see, why this is so complex. This is a good way to clear just cache for one store procedure without, flushing everything else. So I'm just doing it for demo purpose. Now, if I run this with 1057, because I cleared the cache, there's no plan. This time you will see that you get that 118.667 because now it's a new plan. And what I've been talking to you for a while, if you go here now, you'll see that both numbers are same. Because we evicted that plan, we got a new plan, right? Magnus, we have 2 more minutes. Should we pause here or we should continue? What do you want? Like, I have 2 more, but folks can download those and run it by themselves. Or is it?
I'm good if you continue. I have time.
Okay. Okay, great. Okay. So yeah. Folks, if you have to go, I know it's a working time. If you have other meetings, thank you so much. I'm going to continue, but you can download all this and play it and get back to me if you have questions. I'll be extremely happy to answer that. So, but we'll be here just another 5 minutes. That's it. So the next one is unknown. I talked about null a lot, and it's not just null. If you pass variables, compile time SQL Server doesn't know. So you can have issues with that. So just so be aware of that. So here we are using a different thing, order ID. I'm sending you the 1025, and this is a perfect case because this is a unique column, right? So unique columns. Engine is smart enough, you don't have to worry about it. Now, if we change this to a different one, contact person ID with 1025, we always saw it should be 89, right? We knew that, we have seen that many times. But what happens here? What happened to my 89? Now I'm getting a different one. This is new. We didn't see this before. What's going on here? If you remember, I did not pass 1025 actually. I passed this. So compile time, SQL Server engine has no idea what value I'm calling it with. It only sees this. And doesn't matter what number I put here, it will always be 111 point, whatever it is. And where does that number come from? Again, the density, I told you, we'll be using it a lot. This is a hard-coded formula. You cannot do anything. I mean, you can recompile each time. You have other tricks and tips. But if you're just doing this way, passing variable, which is very common practice, that's why this number is going to get generated. Now, if you see this now, here I'm just passing this as this, and if I do a table variable, right? And if you remember at the beginning, I said, there are some constructs that doesn't work very good with this. So here I create a table variable. I insert the records from this table, and then now I'm calling that, or I'm selecting from the table variable, and I have the option recompile. I'll show you without that what happens. Get 271. Now, are you going to compile every time? If you're calling this millions of times in an hour on a bigger table, probably not practical. Now, if I take this, you remember we saw 271, right? Look at this now. 1. It has no clue. Hard-coded 1. Now, I've been running this in an older compatibility level. Actually, I should have mentioned this. I'm running this in a compatibility level of 140. I'm telling it, you are a SQL Server 2019, behave like 2017. I did this purposely for demo purpose. I should have mentioned this before. Now, I told you there's some new features in 2019. So I'm going to now tell it, okay, behave like 2019. So in 2019, I can run the same query. Now you say I do not have recompile, right? Without any recompile, I can still get to 271. You see here. So in 2019, there's a new feature. It's called table variable deferred compilation. I put a Microsoft documentation, read there. It's pretty cool. This is helping us a lot. And then, but 1025, I still didn't get 89, right? I'm getting 271. So where is that coming from? So let me show you, right? If you remember, in 1025, we're supposed to get 89, but we don't get this here because we are using table variable or we are using variables. So it's the estimate, right? So, and if you, as you can see, in pre-2014, if I was doing a recompile, I would get 4,468. So it's a lot better. If you see the actual numbers, it's a lot better. Again, can it go other way? Yes, it can, if you try hard. And I wrote some queries again for you. If you want to run the same query in pre-2014, you can run it. We all use this inequality operators, right, in our query many times, so especially if you have like, date, time, and time, columns and stuff. What happens in those times, right? So I'm declaring a variable, and then I'm using it, in many different ways. All of this will have this number. Doesn't matter which one you choose. Why? Hard-coded formula, 30% of the total number of rows. Can you do anything? No. There's a bunch of other ones. I'm not going to do those. You can run this. If you have a like operator, hard-coded 9%. And there are other ones. If you combine those with and or statements, these are the numbers. And some will vary pre-2014 and post, as I've been showing you, so you can run those. Last one. This is a age-old problem. Like I said, if you have a column that's always putting rows at the end with the date time stamp, with identity column, which is always increasing, right? Now, it's not practical to update stats every time, like as you've been saying. So what happens? Like, we've been using this table for a while. We have 73,595 records. We have, these are the stats we have. And if we look at this one stats, if we look at the histogram, look at the last one. So keep the date in mind. It's May 31st, 2016. What will happen now? I'm going to insert some rows with 2017, right? Just for the demo purpose. Go 50 is a trick you can use, or I could have written it with the while, increment up to 50. You can write in, but that's not the point of this talk. So now we did this. If you remember, we had 73,595 records. We added 50 more. So now we have this many records. Did the stats change? No, because it didn't hit that threshold. If we still come here, 2016, May 31st. So what will happen now if I query with this 2017 date? What do you think? It's a problem, right? Because my histogram has no clue about that date. It's not even within a range. It's outside. So it goes to histogram, said, I only have records up to 2016, May 31st. You were asking me data for 2017. What should I do? So let's run this. We know it's 50 because, we just inserted 50 record. We did a control insert. But where is this coming from now? Right here, 34.60, right? If you were on pre-2014, you're out of luck. You just get 1. That's it. A lot better. If you are now, I told you if you're pre-2014, you're out of luck. That's not a good answer, but what you can do, right? So there is a 2 trace flags, 2389, 2390. I'm not a big fan of trace flag. I'm not advocating it. Please put this on in your dev, test it, make sure you're getting what you're expecting, then put it in your prod. Or better, if you can upgrade, right? But sometimes it's easy for me to tell you upgrade, but you have constraints, right? And sometimes you don't make those decisions, right? There are other dependencies, right? You can always advise them, but we all know that. So that's pretty much I have. So let me go back to my slide. Maybe we can finish this here. I'm not going to go to a demo mode. Increase it to. So these are a couple of things that can help you to read more if you want to go a little bit more details. I put a URL here for that 2 trace flags, right? I talked about. So please read this. Do not put in production. Make sure it solves your case. And then this is my contacts again. And thank you, Magnus, and thank you, thanks to all of you for coming and listening. So my first meeting is still 53 minutes from now, or 57 minutes. So I can take any questions, any comments, anything you have. I'll be more than happy. So go ahead, Magnus, back to you.
Yeah, thank you. Well, thank you so much for the talk. I have a couple of talks which are all about statistics and cardinality estimation, so it's close to my heart. I really enjoyed it. I've come across a couple of queries where SQL Server does not use a density vector because it looks like what SQL Server is doing in 2014 and later is to compare whatever it gets from the density vector with the square root of the total row count. And if the square root of the total row count is lower, it's going to choose that one, which I don't understand the math behind it, to be honest. I haven't done enough mathematical statistics to understand the background, but I just know that sometimes it causes a nested loop where I would have wanted a hash match. So it's, the cardinality is hard, and I know Microsoft is putting a lot of effort into making it as good as possible, but it's impossible to come up with formulas that always works. So the good old answer, it depends, is very...
Yeah, because you have modification, right? I mean, like I said, you cannot be keeping up to date with every stats because it will be impossible. It will be like an IO storm behind the scene, right? If you have to do that, right? Especially if you're in a OLTP system that's busy. I had, I worked for Monster.com many years ago when Monster.com was the leading, recruiting, people will always go there. we had tables that we will do updated stats every hour, with the sample, because just to keep the app running, we have this problem, like writing at the bottom or whatever. So yeah, it's a balancing act, but it helps. I find it helps to understand some of these numbers, especially to help our the developers, and to explain to them, right? Hey, why this is the case, or why this is happening is by design and all that. And I don't know everything. Like I said, I admitted, I had email exchange with Paul White, because I wanted to make sure that my understanding is that he's a master of this. Some of the time I have to read his articles a few times, really, to be honest with you, to understand. I'm not that sharp. I'll be, that's why I work in the big ships. As to, I drove ships. I'm not that sharp guy. I just came here so I don't have to travel anymore and do this gig. I find it interesting. But yeah, so I agree with you, right? Even with the new. The improvements in 2017-19, I had a bunch of email with the Joe Sack and Pedro. They say it's not an easy topic. Otherwise, Microsoft wouldn't put hundreds of people. Joe Sack now has a, I'm not going to give you a number. It's in hundreds team in India just working on this, the adaptive, query engine and all that. So
yeah,
if it was simple, they wouldn't put that many people working on this. So.
Yeah, and I think that's going to be a lot of the future, the changes we will see in query optimization or in the execution plans. That it's impossible to predict the data distribution in a table for Microsoft. They won't know what kind of data we put there. They can just use some heuristics to make a good guess, but
exactly.
And so I think the adaptive part is going to be, we have the memory grant feedback, we have the adaptive joins, and I think we will see more of it, to be honest.
Yes, the whole team is there, like Joe Sack, and they're very very nice. Every time I write, they have a email address separate for feedback, and very responsive. They will send you right away. And actually, in one of my talk, I use all of the queries from them, because Joe Sack said, "Go ahead. You don't need to write. Just take it from GitHub, show it to people. The more people use it, the more feedback we get, the better we get together." So I just use just copy paste from their GitHub, and I put the URL at the top to demo those. So yeah, I totally agree with you.
I find this an interesting and very good development with Microsoft. I remember when Steve Ballmer was the CEO, and if anyone mentioned open source, he'd scream and almost get a heart attack. But now they're sharing so much of the internals of what they're doing, and even the code for so many applications. So it's a new world.
Yeah, yesterday I gave a talk in the one you joined before that into a group in Singapore. This is a new talk on the SQL assessment. All the stuff that I use is from Microsoft's GitHub page. Again, this is something that people do not know, and they are happy that we are spreading the this feature, because the more people use it, the better feedback they get, and it gets the product better. So I think even the support team, I don't know if you saw that. The Tiger team put out their queries. They're putting this into the notebook for people to use. So all this is pretty good. So
yeah, I'm trying to keep an eye on the chat as well, but I see people are happy with the talk. So am I. So.
Yeah, I'm going to just put the link in the chat so people can download from my repo. I probably have to refresh my repo. So
yeah, I find that hard with my own talks, because if I do a presentation and I present the demo, and then I do the same presentation a couple of weeks later, during the demo, I usually change some of the parameters and add some code to it and remove some of it. And then I do a git push. And then for the people who saw it the first time, it won't be the same code that I showed them. So it's hard to keep track of demo code, I think. There we go. And the nice thing is we get access to all your presentations.
Yes.
That's awesome.
I'm okay with, this is most of this I copied from other places and modified, and I learned from other people. So
Yeah.
I have no, and someone said, there are, I mean, there's no reason to keep your queries under lock, because there will be no use with the newer versions anyway, right? So the more you, and I always, what I always tell people, I'll give you everything I have. When you make improvement, give it back to me. And actually, few people sent to me, like I still have a query that Erin wrote for stats purposes. I added a few things, and I remember there's someone in Europe. He wrote a query many years ago about indexes, and then I added a few things with newer version. I sent it back to him. He was so thankful that I did that. So I'm always like, take mine, make improvement, give it back to me. I'll be the happiest person. So.
But I like this, the Microsoft data community. I mean, I think there is something behind it being called the SQL family, because it's a lot more open and sharing. I worked with an IBM champion on DB2, and he was so, he couldn't understand why I would go to SQL Saturdays and talk for free. It's like, but the organizers make a lot of money on it. I'm like, no, they do it for free as well. They use their own money to organize the SQL Saturdays if they don't get any sponsors. So I like that about the community. And sure, it would be nice to get paid sometimes, but then I would have to pay a lot to go to see other speakers. So it's for the good of for the whole community, I think.
A lot of people struggle to grasp this idea of the way we do things with the SQL Server community. I was asked that question blunt one time in LA, because I'm from East Coast. So there's 3 gentlemen during the break time. I don't know for what reason, they just came to me and said, can we ask you a question? I'm like, oh, sure. How much you get paid for this? And I was like stunned. I kind of paused for a few seconds. I'm like, I don't know them. They didn't introduce, and I'm like, no, I didn't get paid. And they were, you could see their face, right? And I till this day, I don't know why they asked me that question. I said, no, I bought my own plane ticket. I'm staying in a hotel. I had to rent a car because I want to go to the speaker dinner. So all I paid from, and someone that I worked with, sent me another email many years ago. He said, do you do this? Does this equate to your salary increase at your full-time job? And I answered very politely, as polite as I could be, but it just bothered me with those, because as I told you, I actually worked in merchant ships, and I went all over Europe, all over the world. And I came to this at a later age, and I always keep that in mind. And I'm like, people like, in Boston area, like, Adam Mechanic, Alan Hart, Grant Fritchie, Mike Walsh, they helped me immensely.